Good afternoon, good morning, and good evening, ladies and gentlemen. Welcome to our webinar series. We are absolutely thrilled for you to be joining us today. We have a very exciting topic on serverless computing, and we will try to cover a broad range of content here. I would really like to encourage you to ask us questions. You can ask questions by clicking on the questions mark button at the bottom right corner of your screen, and we will discuss these questions towards the end of the webinar. My name is Nishant, and I am your webinar host today. Currently, I am a solutions architect at Alibaba Cloud's San Francisco office, and I work with our customers in the North American market. In my current role, I assist executives, technology evangelists, and entrepreneurs in realizing their vision to build highly scalable and resilient businesses by using cloud-based technologies. Please feel free to connect with me via my email or through LinkedIn if you have any questions in the future. Serverless computing has been dominating the headlines, tech shows, and industry conferences. Even though the idea of serverless has been around since 2006, it's a relatively new concept. A lot of people seem to believe that serverless is a natural evolution of the IT infrastructure. During the course of this webinar, we will explore the key concepts of serverless computing and introduce function compute. Function compute is Alibaba Cloud's event-driven and fully managed compute service. Function compute enables users to build and run applications with minimal effort on underlying compute infrastructure. We will also explore some of the basic architectural patterns and how to get started with serverless computing by using Alibaba Cloud's function compute. So here's the agenda for today's webinar. We will start by exploring the evolution of serverless and how serverless technology is helping businesses become more agile. Later on, we will give you a very quick introduction about Alibaba Cloud and some of the core serverless products that are offered in our public cloud. Then we will take a deeper dive on function compute, Alibaba's event-driven and fully managed compute service. So over the last few decades, enterprise IT has evolved at a very rapid pace, from physical servers to virtual machines and then to containerization technology. We have come a long way from the very first generation of computing, which from what I remember in my college days was based on von Neumann architecture. And those machines employed fixed programs. These programs usually were very tightly coupled with the hardware that they ran on. As we transitioned toward disk-based storage, the operating system became less dependent on the hardware it ran on. However, software applications became to resemble like a monolith, in which the user interface and the data access code were combined into a single program running on one single platform. These monoliths were self-contained, and any changes needed to the functionality required a huge undertaking. While the operating system became less dependent on the hardware they ran on, the applications themselves became more dependent on the operating system. In the early 2000s, if we had to launch a new application, we probably had to plan a purchase of a new physical server first. So in summary, the physical server became the building block for an application. Then in 2001, virtualization technology started to gain traction as hardware became more commoditized, especially driven by your x86-based hardware. And that made virtual machines very popular. Hypervisor software, made popular by companies such as VMware, made it easy to create virtual machines. By running many virtual machines on one physical device, the need to buy physical servers became less, and the architectural building block shifted from a physical server to a virtual machine. While virtualization made it easy to operate machines, virtual disk images were rather large and clumsy, and were not easy to scale as required by the volatile computing workloads. Container technology enabled operating system level virtualization, and that proved to be a much more lightweight alternative instead. Along the way, we saw several other major developments. We are going to mention a couple of these now. So in 2009, Heroku, which popularized platform as a service, enabled a containerized 12-factor application via Buildpack. Then in 2010 came along OpenStack, which brought together several diverse groups of vendors, and it created an open source infrastructure as a service. In 2011, Cloud Foundry and open source PaaS, along with similar tools, helped accelerate DevOps movement by supporting continuous delivery over the entire application development lifecycle. Cloud Foundry's container-based architecture ran apps in any programming language over a variety of cloud service providers. And then in 2013, along came Docker. Docker created a containerized standard which became an instant hit among the developer community. So in summary, the containerization technology made it easy to build and deploy microservices-based architectures, enabling further loose coupling and much greater scalability. So fast forwarding to today, several challenges still remain. So for instance, capacity planning is still not trivial. Infrastructure engineers have to plan how many computing resources may be needed, such as how many or what size of machine types would need to be configured. And usually this is based on a ratio of CPU to memory to bandwidth and so on. Overestimation can lead to increased costs, and underestimation could hurt your business. Machine level auto scaling is cumbersome. In some instances, it may take several minutes to scale out. Management of real-time auto scaling and load balancing takes a lot of planning effort. And of course, similar arguments can also be made around fault tolerance, operations, and maintenance. Some of these challenges, of course, can be addressed by many open source solutions that are available in the market today. However, they still require a lot of resource commitment, and they're not trivial to execute, especially if you are a small or medium-sized business. So at Alibaba Cloud, our goal is to provide a leading infrastructure and operations-enabled platform in order to help developers focus on application delivery, rather than worry about the management of infrastructure. So before we go further into the details on how Alibaba Cloud can help alleviate such challenges, let us quickly cover what serverless entails. Serverless architecture, which you may also have heard of being referred to as functions as a service or backend as a service, enables execution of an application with stateless containers. These containers are created right at the moment an event occurs and triggers a need for an action. In short, it is event-driven. It describes a finer-grained deployment model where applications bundled as one or more functions are uploaded to a platform and then executed, scaled, and built in the response to the exact demand needed at the moment. Serverless does not mean without a server. Rather, infrastructure orchestration details are hidden from the user and managed by the serverless platform provider. It goes without saying that containerization technology set the stage for the widespread serverless computing by abstracting away the server and operations and any infrastructure level details and simplified the process of building and managing distributed applications. To recap, here are some of the key features of serverless technology. Serverless enables simplified DevOps. One of the key advantages of serverless technology is that it enables us to build and run applications and services without thinking about servers. With serverless computing, provisioning, scaling, and management of server details are no longer necessary. Developers can forget about management of the infrastructure over which the service is executed, and they can really concentrate on building business functionality. The beauty of serverless approach is that it is applicable to nearly any type of application or a backend service, and it applies to all sizes and the maturity levels of organizations. Besides simpler operations, this approach also allows for the ability to achieve massive scale with minimum human capital, making developers and companies alike more agile. The second advantage of serverless is that it is perfectly suited for microservices based architecture. It also provides us with a high level decoupling between different services. All the decoupling that happens actually favors the development of architectures based on microservices. This greatly facilitates the development of architectures based on continuous rollouts in addition to simplifying the rollbacks as needed. Third, serverless technology enables metered billing, and you pay only for the resources that you use, which is quite different from if you were to, let's say, provision containers where you may have instances where you have resources that are idling. So essentially, in this model, there's no idle. Extending that to your cost of computing, the serverless computing only makes you pay for the computing resources that you actually end up using. So usually, if the architecture is done appropriately, this will result in lower costs. Another advantage is that SaaS companies who sell services that are paid on a per use basis find this model much easier when it comes to tracking their own costs and then passing that along to billing their customers. And not to mention, high availability becomes automated and built in. So Alibaba offers all the tools that are needed by developers in order to start their serverless journey. In this webinar, we will specifically talk a bit more about our core serverless compute product called Function Compute. Function Compute can dramatically enhance agility and lower operations costs for enterprises or startups, enabling them to better concentrate their investments on business critical deliverables and outcomes. The serverless community is growing very fast, and we see many web, mobile, or data processing backends that are being built using serverless components. Emerging patterns that fundamentally leverage serverless approaches include chatbots, big data computing, machine learning, and Internet of Things. Importantly, in all these patterns, using Alibaba's function compute allows developers to focus on developing business logic instead of infrastructure related code. Later on, we will talk about some of these patterns. So I quickly wanted to show you this screenshot that I took today from the Cloud Native Computing Foundation's landscape. And this landscape shows us the hosted serverless platforms. Alibaba Cloud is proud to be a member of the Cloud Native Computing Foundation. Besides Alibaba Cloud, you may recognize some of the other products offered by companies ranging from AWS to Google and so on. Personally, I found CNCF's landscape quite informative and would really encourage you to explore this website in more detail at your own leisure. You can also look at the work that is being done by their working committees on serverless by looking at their GitHub pages. So moving on, I recognize some of you may be wondering what Alibaba Cloud is and how does Alibaba Cloud help businesses like yours. So I will spend just a few minutes to give you a brief introduction about Alibaba Cloud. Alibaba Cloud is the cloud computing arm and the business unit of Alibaba Group, one of the largest e-commerce companies in the world. Alibaba Cloud provides a comprehensive suite of global cloud computing services to power both our international customers, online businesses, as well as Alibaba Group's own e-commerce ecosystem. Here are some of the stats, and not all these stats may be up to date, but this will still give you a pretty good idea about Alibaba Cloud. So Alibaba Cloud has over 1 million paying customers, ranging from some of the largest enterprises to small and medium-sized businesses. Alibaba Cloud operates data centers in 19 different geographic regions and offers 52 availability zones. With over 1,500 network nodes, you can practically build a global business with the click of a few buttons. For any further information about Alibaba Cloud, please feel free to visit our website. Our website is www.alibabacloud.com. I would highly recommend you to sign up for a free account and have a go at trying at some of these products. This slide here shows the infrastructure map, and just to introduce a couple of terms around infrastructure, one of them is called a region and the other one is a zone. A region refers to a physical node on a global scale, and each region is composed of multiple zones. A zone is composed of one or more multiple scattered data centers, each of which has an independent supporting facility, and this facility could be your power supplies, your networks, and your connectivity, and so on. A zone helps you improve the efficiency of production apps and databases and helps you create higher availability. Just in case one data center goes down, the other is there as a backup. The map here shows all the regions and availability zones along with the CDN nodes. You can see the CDN footprint here. There's over 1,300 nodes in China, and there's well over 200 nodes around the world, and we continue to add more every single day. In China, we have the number one coverage with 7 different regions. And some of our customers really appreciate, especially the ones who are going to start businesses in China or in Asia, we have specialized products just to meet their needs. I'm not going through the detail of this slide here, but this is just to give you an overview of all the different layers that Alibaba helps you build for your digital business. So besides the infrastructure and being able to provide you with software such as operating system or databases or storage, we also offer platforms for computing, including graph, stream, or batch computing. We have platforms for machine learning and AI, and we also have some of our flagship products for enterprises, which helps them create large distributed data warehouses. And on top of that, we also offer bespoke industry solutions. One of the most fundamental attributes of cloud computing is information security, governance, and compliance. From data centers to end users, Alibaba Cloud ensures that the security and privacy of data through comprehensive security capabilities. Rigorous physical security measures safeguard the data centers, and advanced logical security technologies prevent unauthorized access to the networks. Alibaba Cloud adheres to domestic and international information security standards, as well as industry requirements. Alibaba Cloud is also constantly improving the management and security of our information technology systems. This includes undergoing regular third-party evaluations and reviews from numerous certification authority agencies. So here on the slide, you can see some of the major third-party audits that Alibaba Cloud's data centers have undergone, and you'll see all the major certifications that are well respected around the world. And for any other further details on the information security aspects, please feel free to visit www.alibabacloud.com/trust-center. That's spelled CENTER. All right, so in the next few slides, we're going to give you a brief introduction to some of our key serverless products, and then take a deeper dive in function compute. So here's a quick overview of the serverless products that are offered by Alibaba Cloud. As you can see, many of the cloud services, such as computing and storage, are serverless. For example, OSS or Object Storage Service is one of the first cloud services launched by Alibaba Cloud, and it's a serverless storage solution. Users do not need to care how data is stored on the underlying server, and they only pay for storage resources that they consume. So talking about function compute. So function compute is an event-driven and fully managed compute service. With function compute, you can quickly build any type of application or service without considering management overhead. Function compute prepares computing resources for you and runs your code on your behalf elastically and reliably. It also provides you with log query, performance monitoring, alarms, and several other features. And the best part about this is you only pay for resources that are actually consumed when running the code. There's no fee incurred when the application code is not running. So I wanted to break down some of the definitions or the terminology. So functions are essentially segments of application code that run a specific function and are used to basically execute some sort of logic. These functions are triggered by an event, and an event could be a change in data state, a request to an endpoint, or a change in the state of some resource. You can use the handlers provided by function compute to write your code, and then you deploy the code as functions. Services in function compute are essentially, it's a collection of functions, and the best analogy here is that it corresponds to your microservices in your software application architecture. When you build an application in function compute, you must abstract service logic into microservices, and then you implement those microservices to build your applications. Now, I know that was a bit too much, so what we'll try to do is we'll try to attempt to give you a very quick peek on a very simple workflow to kind of illustrate how function compute actually works without getting too technical. So again, looking at this slide, so let's imagine you're a developer, and so you would basically design or develop some sort of a code, and this code could be in several programming languages. So as of today, function compute supports the major programming languages, including Java, Node, and Python. More application programming languages are being added in coming months. So once the code is there, the developer will upload the code on the function compute. Now, there are several ways to upload the code. The easiest one is to basically go onto the console, access function compute, and then just paste your application code there. For advanced users, probably it's easier to use an API or an SDK. And for really advanced users or those who prefer to use command line, we have a command line tool called FCLI. So depending on the code, we can set up an event that will trigger to call to our function so that our function can run. So some of the common trigger methods include OSS, API gateway, log service, table store, and many other methods, which we're going to talk about shortly. So once the function compute code is triggered, the function compute will dynamically manage the execution of the code based on the amount of user requests. And it guarantees the performance of the peak requests. So real-time auto-scaling is one of the core strengths of function compute. The function compute system monitors user load changes, and each component dynamically resizes based on the user load. And finally, when you see the bill, you'll see what's actually been consumed as your application code ran. The billing granularity is 100 milliseconds, so it's very granular, and more on the billing. We're going to talk about the components in a few minutes. So we saw earlier that function compute integrates different services in an event-driven manner. So when the event sources service triggers an event, the associated function is automatically called to process that event. You can trigger function invocation by using Alibaba Cloud products. So here on this slide, you see some of the core products. You see a product called API Gateway. You see Bbot, which is Alibaba's chatbot solution. You can use a CDN. You can use a table store product, and so on. One of the other unique features, and from my understanding, last time I checked from some of the other leading public cloud providers, Alibaba Cloud is one of the only cloud providers that actually lets you use an HTTP trigger. So what that means is that when you use an HTTP request to trigger the execution of the function, you can quickly implement web services by using a head or a post or a put or a get method to trigger that piece of code. And finally, you can also use timer triggers, which can be a schedule, or it could be a specified time when you want to run your application code. So to recap, as you can see, we can pretty much build an unlimited number of use cases around function compute. So here on this slide, you can see if you're working on use cases that require integration with IoT devices, you can have your device trigger some sort of a event through the IoT through a gateway, and then that can trigger the application code. Or you can have a different actor. You can have users, you can have your mobile applications, you can even have a transaction that triggers an event. And yeah, I mean, it really allows you to build all sorts of applications. Here we have just sort of given some examples: image editing, video transcoding, content distribution, and so on. So what we're going to do is we're going to spend a few minutes just talking about some of the common patterns we see in implementing function compute. And this will really solidify sort of like how can you implement function compute in a real world scenario. So one of the first patterns we're going to talk about is how to build an analysis and management service of media assets. So let's say you run a media company and you get a lot of content, videos or pictures and so on. And so in the following architecture, what we've done is we've built an event trigger mechanism in order to create a full data processing workflow. So anytime we upload objects onto the OSS service, multiple functions are triggered to perform different tasks. One task could be extracting metadata from, let's say, an image. Another task could be transcoding a video feed into different formats, and so on. So with this event-driven model, we can quickly integrate different services to build an elastic and a highly available backend video system. And in this case, we went further and then we integrated another product called Max Compute, which is a large-scale distributed data warehouse solution from Alibaba Cloud. The second pattern that we are going to discuss here is how to build a serverless backend service. So again, function compute and API gateway are used to build backend services to verify and manage API requests through API gateway product. The flexible serverless architecture enables us to scale up or down to handle changes in the requirements and build various applications. So you can see here we have a service for search, we have a service for a social media update, we have a push notification based on messages, and so on. And the real-time auto-scaling and dynamic load balancing within milliseconds really helps us manage bursts very efficiently. And the third pattern we are going to talk about is how to build a real-time IoT message processing service. So again, in this architecture, we are able to process real-time data streams from IoT devices. We ingest the data with Data Hub, which is another Alibaba Cloud product, and use the incoming data to perform various types of actions. These actions include filtering, aggregation, and analysis of incoming data. And then further on, we can take the results of the analyses and then we can convert that into structured data and store it in a database. Lastly, we're going to quickly mention the core components that make up for the pricing of function compute. The first component is really the requests, and these are requests that are made to the piece of code that was embedded inside the service as a function. It's worthwhile noting that the first 1 million calls per month are free of charge. Usually resets are done first of every month. The second component is duration. So this is like this is where we will probably see the majority of the costs, and this is the biggest component. And this really measures how much resource are you actually using. So an execution duration starts when your code begins to run and ends when the result is returned or execution is terminated. And as we mentioned before, the measurement granularity here is 100 milliseconds. And then the duration price really depends on the memory size that you have allocated to your functions. And then finally, of course, if your application code or your functions are using any network bandwidth over a public network, then there are associated fees, which are common to almost all of the Alibaba Cloud products. So thank you for listening to the webinar. I hope this was helpful for you to kind of just get a glimpse of what's happening in the serverless world. And now we're going to take questions. So if you have any questions, please feel free to click on the question mark button on the bottom right of your screen. Thank you again. Hi, everybody. So we've had a few questions that we are going to discuss now. So one of the first questions was, how does Alibaba's serverless product compare to the others? And this includes other public cloud providers such as AWS and Google. So just to recap what we just discussed, what we saw, Alibaba Cloud has a portfolio of serverless products, just like some of the other service providers. So in the webinar, we looked at some of the different types of products. So as an example, for storage, we have a product called OSS, which is Object Storage Service. For data store, we have Table Store. For messaging, we have Message Queue. For API proxy, we have a product called API Gateway, and so on. And then obviously for compute, we have several products, but perhaps it's worthwhile just to take a quick look at the function compute, which is a comparable product to AWS Lambda. So from my understanding, these products are pretty much similar in terms of features. Some of the things I wanted to point out, the function compute from Alibaba Cloud, in terms of the languages, it does support PHP, whereas from my understanding, last time I checked, PHP is not supported by AWS Lambda. For Google, I believe only supports Node and Python, and Azure supports Node, C Sharp, and some of the other languages. So we do support PHP, which if you are a PHP shop, you might find that more useful. Some of the other differences, one other difference is around cold start. So function compute in terms of cold start is under 200 milliseconds, which is pretty much similar to AWS Lambda. But from some of the numbers that I've seen before for GCP functions and for Azure functions, it takes slightly longer for a cold start. Also, on the Alibaba function compute, we support a maximum duration of 15 minutes for a function to execute. And you can look at some of these in detail on our documentation. Okay, there was a second question, and I'm just going to read out this question quickly. So the question says, so we covered some of the key features in the webinar on function compute. What other resources can I use if I wanted to get started with function compute? Do you have a guide for new users? Yeah, so that's a pretty good question. We try to make this webinar generic so we could cover non-technical users. Now, so in terms of getting started, we do have a couple of suggestions for you. The first suggestion is to essentially, if you already have a Alibaba Cloud account, you can just simply go into the console and you can start playing and you can write your first function. And there's a very well-written guide in our documentation. If you would like to access the documentation, you could go on our website, which is www.alibabacloud.com. On the top navigation bar, you will see a link for documentation. And once you click on that link, you will see the landing page of the documentation. Here, under Elastic Computing, you will see the documentation page for function compute. And once you're inside the documentation, you will see a quick start guide. And inside the guide, we have tried to write a for you like a guide for you to write your first function, hello world, which it's a very simple function. If you started learning programming, this was probably the first program you may have written, which is to print out hello world. And so this guide will walk you through that process. The second suggestion is for you to take a certification course, and we have mini certification courses called Clouders, and these courses are again available on our website. Again, if you navigate to the top navigation bar and go into Alibaba Cloud Academy, you'll see on the left-hand side there's a section that describes Alibaba Cloud Technical Certification. And if you click on a link which says Learn More, and then you'll see under Cloud Computing Specialist Certification, if you just browse down a little bit, there's a course called Deploy an Image Process Service Using Function Compute. And this is a hands-on, sort of like a video webinar, similar to this one, where you will basically build a image processing service using function compute. So those were some of the resources available for you. And the one of the questions here was asking us about the differences. So the question is, when should I use function compute versus ECS, which is the Elastic Compute Service? So this actually is in our FAQ document. So I'm just going to quickly read what we are trying to say here. But essentially, the gist of it is really depends on your use case. For ECS, you have more flexibility, and you can basically configure a wide range of instance types depending on your requirements, if you already have those requirements well laid out. And it allows you to customize your own software stack solution end to end. And also, obviously, you have full ownership and control over the ECS virtual machines that you would spin up. And the other advantage of using ECS is you can really define at a very granular level your scaling logic depending on your business use case. Whereas function compute, as we discussed in this webinar, it basically abstracts all the management of the underlying infrastructure. So if you're a developer looking to just get started right away, function compute would be a good alternative. So that ends our webinar Q&A. Thank you all for attending today's webinar. Have a good day.